In this video, let us look at the concept of characteristic equation of a square matrix. So let us say that A is a square matrix of the order n by n. Now, determinant of A minus xi is equal to 0 is called the characteristic equation of the matrix A. For example, so if A is the matrix 1, 2, 1, 3. So what is the characteristic equation of this matrix? So A minus xi is nothing but 1, 2, 1, 3 minus x times I is x0, 0, x, right? x0, 0, x. So A minus xi is 1 minus x, 2, 1, 3 minus x. So the equation determinant of A minus xi is equal to 0 is called the characteristic equation. So determinant of A minus xi is equal to the determinant of this matrix, that is 1 minus x times 3 minus x minus 1 into 2 is equal to 2 is equal to 0. That implies 3 minus 3x minus x plus x square minus 2 is equal to 0. This implies x square minus 4x plus 1 is equal to 0. So this is the characteristic equation of the matrix 1, 2, 1, 3. So similarly, if you have a 3 by 3 matrix, you get a cubic equation. If you have a 4 by 4 matrix, you have a 4th degree equation. For a 2 by 2 matrix, you have a quadratic equation. Now, what is the importance of this characteristic equation? What is the importance of this characteristic equation? So there is a very important statement that you need to understand with respect to the characteristic equation. So the statement is, it's very important. Every matrix satisfies its characteristic equation. Every matrix satisfies its characteristic equation. There is the matrix A 1, 2, 1, 3 has this as the matrix equation, characteristic equation. Now the statement states that the matrix A satisfies this equation. That means A square minus 4a plus I will be equal to 0. So you can try to calculate this a square minus 4a plus I, and it will turn out to be a 0 matrix. So this happens with every matrix. Every matrix satisfies its own characteristic equation. So this is a very beautiful statement which will be useful in finding the inverses of certain matrices. For the sake of completion, so let us check whether this matrix actually satisfies this equation or not. So first, what is A square? A square is 1, 2, 1, 3 times 1, 2, 1, 3 is equal to 1 plus 2 is 3, 2 plus 6, 2 plus 6 is 8, 1 plus 3 is 4, 2 plus 9 is 11. So what is A square minus 4a plus I? So A square minus 4a plus I is 3, 8, 4, 11 minus 4 times A is 4, 8, 4, 12 plus I is 1, 0, 0, 1. So this is equal to, so as you can clearly see, 3 minus 4 plus 1 is 0. 8 minus 8 plus 2 is again equal to 0. 4 minus 4 plus 0 is 0. 11 minus 12 plus 1 is again equal to 0. So as you can very clearly see, A square minus 4A plus I is equal to 0 matrix. So we have verified that the matrix satisfies its own characteristic equation. So every matrix does this. Now, what is the use of this? So this characteristic equation is very useful in finding inverses of given matrix. Suppose that you are asked to find the inverse of this matrix. So we already have two easy ways. One is using the transformations. The other is using the method of cofactors. Adjoint of A by det A. Now let us use this method to find the inverse. So we know that A square minus 4A plus I is equal to 0 because it is the characteristic equation. Now I'll multiply the whole equation with A inverse. So A inverse times A square minus 4 times A inverse times A plus A inverse times I is equal to 0. So we know that one A inverse and one A gives I as the answer. So A inverse times A square is A minus 4I plus A inverse is equal to 0. So A inverse has to be equal to 4 times I minus A. So A inverse have to be equal to 4 times I minus A. So for this, A inverse is equal to 4004 minus A is 1213. That is equal to 3 minus 2 minus 1, 1. 3 minus 2 minus 1, 1. So we can also find the inverse using the direct formula. So 1 by det A is 3 minus 2 is 1. So 1 by 1. And you interchange the diagonal elements and change the signs of non-diagonal elements. That is equal to 3 minus 2 minus 1, 1. So you can see that you got the same answer from both the methods. So the concept of characteristic equation gives you an alternative method to find the inverses of given matrices. So let us take another example involving a 3 by 3 matrix. So let us say that A is 1, 2, 1, 2, 1, 3, 1, 1, 1. So what is the characteristic equation of this matrix A? So the characteristic equation of this matrix A is det of A minus xi is equal to 0. That is det of, if you subtract x times I from A, you get 1 minus x, 1 minus x, 1 minus x, and all the remaining elements will remain same, is equal to 0. So that is 1 minus x times 1 minus x whole square minus 3. 1 minus x whole square minus 3. Minus 2 times 2 minus 2x minus 3. So 2 minus 2x minus 3. Plus 1 times 2 minus of 1 minus x. That is 2 minus 1 plus x is equal to 0. So this implies 1 minus x into 1 minus x whole square is 1 minus x whole cube minus 3 minus x minus 3, plus 3x minus 3 plus 3x. So 2 minus 3 is minus 1. So plus 2 times 2x plus 1, that is plus 2x plus 1. So you get plus 4x and minus 4 plus 6 is plus 2. So plus 4x plus 2, 2 minus 1 is 1, plus 1 plus x is equal to 0. So this implies 1 minus x whole cube is 1 minus 3x plus 3x square minus x cube minus 3 plus 2 plus 1. So this gets cancelled. So 3x plus 4x plus x is 8x is equal to 0. So this implies if everything goes onto that side, you get x cube minus 3x square. So you have plus 5x here. If it goes onto that side, you get minus 5x. Minus 1 is equal to 0. So because it's a 3 by 3 matrix, so you get a third degree characteristic equation. Now, what is the corresponding matrix polynomial? What is the corresponding matrix equation? So the matrix A satisfies the corresponding characteristic equation. That is A cube minus 3a square minus 5a minus I will be equal to a 0 matrix. So this is the equation which the matrix A satisfies. So sometimes in questions what you're asked is, you'll be given a matrix and you'll be asked something like this: A cube minus 3a square minus I equal to how many times A? So instead of calculating the matrices, mostly such questions are based on the characteristic equations. So you just need to find the characteristic equation and compare the question with the equation, you get the answer. So here again, this characteristic equation will be useful to find the inverse of this matrix also. So if you multiply the whole equation with A inverse, so A inverse times A cube is A square minus 3 times A inverse A square is A minus 5 times A inverse A is I minus I times A inverse is A inverse is equal to 0. So A inverse can be written as A square minus 3A minus 5i. So if you find A square minus 3a minus 5i, you will directly get the inverse of this matrix. Inverse of this matrix. So I urge you to find the inverse by this method and also by the cofactors method and compare if they are equal or not. So if all the calculations are equal, or if all the calculations are correct, they have to be equal. Thank you.